Yes, for 9a you can factor out the x. And that's what we're going to do first. Anytime you see a polynomial and every term has an x in it, factor it out. It would be like seeing an equation where every number is even. Well, you could factor out a 2 then, right? That whole concept of they have something in common, so let's factor it out. So we're going to bring an x out front, reducing every degree by 1. X cubed becomes x squared. 5x squared becomes 5x, and 14x becomes 14. So that's what it looks like when you factor an x out. And I don't think you'll even need a calculator for this problem at all. Because at this point, if you're not good at factoring, you need to get there soon, all right? To factor this trinomial, it's pretty basic quadratic. X times x makes x squared. We're going to need a plus and a minus to multiply to a negative. Okay? And I need factors of 14 that differ by 5. What do we get? 2 and 7. The 2 being the plus and the 7 being with the minus. The 7's with the minus because it needed to win in the middle to become minus 5x. So the minus gets the bigger digit. So we have now factored it, and the zeros are, what would you put in here to produce 0? Anytime there's a lonely x out front, 0 is one of the zeros. What else? -2 and 7. All right? So that's 9a. Factor it. Those are the zeros. 9b is rather convenient in that they tell you one of the zeros. You might not get that hint on the test. So go ahead and graph it and see where one of the zeros is. You know, that's always a good start. But then I would want you to show the work in finding the other ones, in doing synthetic division or long division. If that still doesn't help you, try the rational root theorem, where you do the p's and the q's. We'll do one of those a little bit later. But let's approach this one with synthetic division, since we already saw a long division problem today. So when they tell you 1, 0 is 5, we change color so it doesn't blend in with the other one. When they tell you 1, 0 is 5, that's the number in the box. The 0 is the number in the box. Then you look at the polynomial that they gave you, and step 1. Ask yourself if they accounted for, if every degree is accounted for as you work from left to right. X cubed, x squared, x, and a constant. We don't have to fill any places with zeros. If the x term wasn't there, you would need a 0 to hold its spot.
So if 1, 0 is 5, why is the number in the box?
If 1, 0 is 5, why is the number?
You said that the number in the box will be 5.
The number in the box is 5.
Oh.
Okay, we're good. So we have 5 in there. We need the coefficient from x cubed, 1, x squared, 3, x, and the constant, -60. Now, synthetic division is basically not division. It's addition and multiplication, and it's going to help us find the other factor of the problem. It's going to help us figure out what the other set of parentheses would be that x minus 5 would be multiplied by. So this polynomial p that we started with can be broken down into x minus 5 times, we don't know. We're trying to find the we don't know right now. I know that x minus 5 is a factor because 5 is one of the zeros. If 5 is a 0, then x minus 5 is a factor. Here's how synthetic division works. You put a big line under it. Bring the 1 down. 5 times 1, 5. That's not a decimal point, okay? Add. 8. Multiply. 40. And you can already see, I think it's going to work out, because -28 and 40 makes, and 5 times 12 is 60 plus -60 is 0. So that remainder part is 0. That's great. That means that this column, which started out as x cubed, now is the x squared. This was x squared. Now it's x plane. This was the x column, and now it's the constant. So in my other parentheses, I now know that we have 1x squared plus 8x plus 12. Hopefully that helps you factor it completely. Again, if you're not good at factoring, you need to get there. You need to practice. Go to the internet and print out a big page of quadratics to factor. Or I could do that for you if you need practice with these. And just boom, 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 boom. Do a mad minute or something like that. So this polynomial p can be broken up into x minus 5 times x plus what? Times x plus 2. Because 6 times 2 is 12, and 6x plus 2x is 8x. So my zeros are 5, negative 6, and negative 2. Pretty funky looking 5. There we go. So those are the 3 zeros. Don't believe me? Graph it, check it, see if 5, negative 6, and negative 2 are the zeros. Good night.